Okay, great. Right, so we're moving on to applying our integration or definite integrals that we learned from 17.1, okay, into finding the area between the curve and the x-axis. Okay, or rather in this chapter we will learn three things. Area between the curve and the x-axis, area between the curve and the y-axis, and the last one is area between the curve and the line. Okay, so don't worry about it. It's all about applying what you learned in 17.1 repeatedly over and over again. Okay, which by now you should have already finished the 17.1 lesson that was given to you before the June holidays. Right. Okay, so let's start. All these are the prerequisite knowledge you should know. So all these are the formulas, differentiation, integration, and all are all here. Okay, all summarized for you in one page. Okay, so if you still need to refer, you can still refer to this. Okay, there's also a video link to explain to you why the integration from one x value to the other x value will give you area under the curve. I don't want to go into the details of it because that takes up a lot of time, firstly, and secondly, a lot of y'all won't understand. Okay, it involves limits, which is a little bit advanced lah. If you are interested and you go to JC and you will learn it again, right? So we don't have to go into that details here, right? So I will just take the formula and apply it and then teach you how to apply it. All right. Okay, let's look at the first example. So over here you have a diagram that shows part of the curve y equals to 5 over x squared. Okay, and the graph is drawn for you, right? So you don't have to worry about that part. Find the area of region A. Okay, so region A, as you can see from the graph, is bounded by, sorry, wrong tab. Okay, the region A is bounded by the x values 2 to 3. So this area here. Alright, so by the formula, the area of A is given by the integral from x equals to 2 to x equals to 3 of the curve 5 over x squared. Okay, so if you integrate the function from 2 to 3, you will be able to get the region that is bounded by area A. Are we okay? So this is the application already, right, of what we learned yesterday. So do you all know how to integrate this? 5 over x squared. How to integrate? Emily, how do you integrate? Okay, take out the 5 and then? Very good. Okay, so write it as a power of x to the power of negative 2. And then you apply your power law, right, on your x to the power of negative 2. Okay, you can, like I said yesterday, you can actually pull the 5 out and put it outside the integral. Okay, but I would really advise against that. Keep it inside, but leave it alone. Okay, because if you pull it out, later on you have to expand it back in, which a lot of you will miss out the second term. Okay, so leave it there. Okay, power plus 1, so that gives you negative 1, and then divide by negative 1. Okay, so this is how you integrate x to the power of negative 2. And then if you simplify this, you will get negative 5 over x. Right? And then we'll now find the actual area by subbing in the values of 3 and 2 and then subtracting the 2. So substituting in x equals to 3 and then minus substituting in x equals to 2. Okay, so this is the formula that we learned yesterday, right? How to find definite integrals. So upper limit minus the lower limit. Okay, so take note of the negative sign. That's why there's an additional bracket here. Are we okay? And when you add it up, you should be able to get 5 over 6. Negative 10 plus 15. Yeah. Units square. So this is the answer for part 1. Are you okay? Okay, for part 2, they ask you to find the value of K such that the region of area B or the area of region B is equal to the area of region A. Right? So, area of region B is equal to the area of region A, which means that the area of region B, which is bounded by 3 to K of the expression, is equals to 5 over 6. Right? So that's how we get this equation. And then we don't have to go through the trouble of integrating the whole thing again. We can just directly copy because we already know that the integral will be 5 over x, negative 5 over x. Then we just change the limits from k to 3. Right? And then you sub in your k value and your value of 3 in. So negative 5 over k minus negative 5 over 3 is equals to 5 over 6. Okay, then you solve this. Negative 5 over k is equals to 10, so it's 15 over 6. Correct? No. Negative 5 over 6. So therefore k is equals to? Yes. Are we okay? Can? Alright, so that's how you do example 5. Okay, so now I need to do try it 5. Right? Similar to example 5. Try yourself and then we'll discuss again later.